Hey everyone, and welcome. For the longest time, the story in the world of AI has been pretty straightforward. Bigger is always better. More data, bigger models, more computing power. But what if that whole story is starting to change? Today, we're going to dive into this really fascinating shift, where it's not about having the most data, but having the smartest data. Let's get right into it.
So right off the bat, check this out. What you're looking at are results from a really important benchmark that tests how well AIs can use different tools. And yeah, you see the big names here, GPT-4o and Claude 3.5, but look all the way over to the right. There's a model called XLAM2, which is way, way smaller, and it's actually scoring higher than both of them. No, that's not a typo, and it's not a fluke either. It's a sign that something fundamental is shifting.
And that leads us to the big question for this whole explainer. How on earth is that possible? Seriously, how can a smaller, more focused AI model run circles around the giants that we all know and use every day? Well, the answer, as it turns out, is all about fixing a really fundamental weakness in how these massive models learn to begin with.
See, it all comes down to a specific Achilles heel that even the most powerful models have. They are absolutely incredible at answering a single question. You ask, they answer. But they often hit what you could call a conversational wall, and that happens the second a request isn't just one simple command, but a complex, back-and-forth dialogue with multiple steps.
This is the exact spot where things get tricky. We're talking about multi-turn interactions. Just think about something like planning a trip. First, you find a flight. Then you ask about adding a hotel. Then maybe you ask about trip insurance. And a few days later, you might want to cancel the whole thing. Every single step depends on the one before it. And this is exactly where even the smartest AIs today can really fall flat.
Let's just stick with that travel booking example for a second. When a task has all these different steps, booking the flight, then adding the insurance, then trying to cancel it, it's like a minefield of potential errors for an AI. And there are two really common ways they mess this up, which kind of reveal why this is so hard for them.
Okay, so the first big mistake is something called long dependency. Imagine you go through the whole process. You book a flight, and the AI gives you a booking ID. Great. 5 minutes later, you say, "Hey, can you cancel that trip?" A person would remember the ID, obviously. But the AI, it often completely forgets that crucial piece of information it just gave you. It has a major memory problem, and it ends up asking you for details you literally just figured out together.
And the second common mistake is all about logic, or a lack of it. Think about it. To book a flight, you first need to know how much it costs, right? But what often happens is the AI tries to jump straight to the final step. It tries to book the flight without completing the necessary steps that have to come first. It just doesn't get that some tools have to be used in a very specific order to get the right answer.
So, how do you fix this? This is where it gets really clever. The first brilliant solution comes from a team of researchers at Google and UCLA. And you can think of it as the mapmaker method. The idea is, instead of just letting an AI wander around and get lost, you first give it a perfect map of the entire territory.
This system is called Magnet, and its core idea is actually pretty simple, but it is so powerful. Before it even tries to generate a single training conversation, it first looks at all the tools it has, like a book flight tool or a get cost tool, and it builds a giant graph of every single possible logical connection between them. It is literally like mapping out every single valid road before you even start the journey.
So this four-step process is what's absolutely crucial. First, it gathers up all the tools. Second, it builds that dependency graph we just talked about. Third, it uses that perfect map to generate flawless logical paths, kind of like a GPS giving you the perfect route. And only then, in step 4, does it turn those perfect paths into ideal conversations to train the AI on. It's all about quality, not quantity. And here's the secret sauce, in the researchers' own words. They basically say, look, we connect two tools in our graph whenever the output of one tool can be used as the input for another. It's a simple, really elegant idea, and it's what lets them build that flawless map of every possible correct action from the start. Okay, now for the second solution, which comes to us from Salesforce AI Research. If that first mapmaker method was all about mapping every possible road, this one is different. Think of this as creating a perfect blueprint for one very specific job. This framework is called APIGen-MT, and its big innovation is that it first plans a perfect solution to a problem, and then it verifies that the plan is actually correct. And it does all of this before a single word of a simulated conversation is ever written. And here's how this two-phase process works. In phase 1, the blueprint phase, one AI agent designs a plan. But then, and this is the cool part, a review committee of other AIs checks it for any possible errors. It's just like having a team of architects double-checking a building's blueprint. Only after that blueprint is stamped approved does the system move on to phase 2, using that perfect plan to simulate a totally flawless conversation.
So if you put them side by side, you can see these are two different philosophies that are aiming for the exact same goal. Magnet's mapmaker is exhaustive. It maps out every single possible correct path right from the start. APIGen-MT's blueprint is focused. It designs and verifies one single perfect plan for a specific task. But at the end of the day, both methods are about one thing: creating flawless, ultra-high-quality training data.
So what's the actual real-world impact of training an AI on this kind of smart data? Well, it brings us right back to where we started this whole conversation. The theme is crystal clear. It's not the size of the model that matters most anymore. It's the smarts of its training.
Let's just look at the numbers for a second. The Magnet paper showed that their model saw its performance in these super complex, multi-step scenarios jump by an incredible 32.5 points. That is a massive, massive leap in capability. And it's all from smarter training data, not from building a bigger model.
And this really gets us to the most important takeaway here. The whole race for AI supremacy, it might be shifting gears. Instead of just this brute force approach of scaling up with more and more raw data, the future seems to be about carefully creating and synthesizing perfectly logical, high-quality data. Data that teaches AI agents not just to talk, but to actually reason their way through complex problems step by step the right way. And so that leaves us with one last really provocative thought. We started this off by seeing smaller models outperforming the giants. So if carefully crafted, truly smart data can beat raw size and power, what does that mean for the future? What other hidden flaws in today's AI can be solved not with more horsepower, but with more elegant training? That right there is the next frontier. Thanks for joining me.